questions. When last we met, we were talking about the elements and some funny ways to remember the elements, whether it's through a pun or through everything else. So we had my corny, what did the robber say to the policeman? See you later, copper. FIFO, FOM. Whoops, I do not spell, I smell blood of the iron one. So F.
I still don't get that.
Okay, so Fe is iron.
Yeah, but
Wasn't it Jack Beanstalk was the old story where the giant would always say fee, fi, fo, fum?
Yeah.
Yeah.
Yeah, that's what that was.
Yeah, so that's where it comes from. There, let's see, what other ones did we come up with? I'm going to see if I can get Jesse's picture in here.
I finally found it.
I was gonna say a joke about sodium and hydrogen, but nah.
Okay.
Yeah.
Did you have to go there with that one?
Okay. I was gonna tell a joke about sodium and hydrogen, but nah.
For zinc is, I'm out of chemistry jokes. I should think of.
Oh, where'd it go?
Hippity hoppity around my property.
All right, I'll see if I can figure out how to get, oh, I know what I can do. I can insert a picture.
Zelina Howard.
That's Avery's mom's name.
Oh, okay.
That's good. That's a good one.
Hey, so annoying.
What was the one that Suka gave us?
I don't
Did
remember.
you hear that oxygen and magnesium are dating?
OMG.
Yeah.
Oxygen and
Magnesium.
magnesium. All right, any other good ones? Or any other ones? They don't even have to be good. I mean, I let us off with some doozies there, so.
I had one for zinc.
Okay, what do you got?
I'm out of chemistry jokes. I should think of a new one.
Oh, nice. Okay, so the question becomes, what's the symbol for zinc?
ZN. But it's not in the line.
So it's not in line, so we got to figure out how to get it out in there. Unless we just capitalize the N.
Yeah.
One for chlorine is no one can clean like chlorine with the capital C-O.
I got so Cl.
Kind of off topic, but you guys realize it's almost been a year since the Abbey's burned down?
I didn't know Abby's burned down.
I didn't even know that happened.
What
Wait,
burnt down?
does chlorine have an H in it?
Are you
Probably.
talking about the one in France?
Yeah, that giant fire with the giant
Yeah.
monastery. I forgot
Yeah,
the name.
chlorine is CH.
What'd you say, Suga?
Notre Dame.
Notre Dame. Yeah, that one.
Notre Dame.
What?
Is it no one can?
It's been almost a
clean?
year.
So chlorine Cl, right? So
Yeah,
is it no one can clean?
Yeah, no one can clean.
Okay.
Jesse, you know whose birthday it was a couple days ago?
Who?
Chester Bennington's.
Well then.
It was also Ewan McGregor's birthday.
You not know who that is?
Do you
I
want
do.
us to write these down, or are
Probably
you
one
gonna
of the
like?
members.
I will save this and then
I do, Jesse.
I can send it on a link or stick it on RunWeb. If you want to write it down, you can, since we had such a joy of a time trying to figure out how to download this last time.
Okay.
I have one, but I'm not sure if it makes very much sense.
All right, what do you got?
When these two elements combine, they have these letters within: H, I, J, K, L, M, N, O, P. What is it? And then I said H2O.
So when these two letters combine, they have these letters in common.
Yeah.
I don't get it.
Okay, which were the letters?
H,
I
I, J.
Okay,
I get it because it's H to O.
Yeah.
yeah.
Oh, that's funny. That's a good one. What do you call a stupid element? Boron.
Nice. So H, 2.
Oh, but that doesn't.
That's a 0.
Well, just
Okay,
on the
so-
first sentence.
Yeah, so that one, a nice punny joke about water.
Yeah.
That's all right. We'll leave it in there. Okay, any others coming to mind?
The element of silence, sulfur and hydrogen. But that doesn't have like
Of silence?
yeah. Like sulfur and hydrogen.
Sulfur and hydrogen? Okay, how does that help us remember S and H?
Because
They did one.
SH makes the sh sound. Sulfur is just
But
S.
doesn't have it like it's a joke, but
So that makes it S.
Hey there, so I have this client, Martina Morgan, on the line. She's calling in regards to her dad who's deceased. He was also
That
one
makes
of
the,
Jay,
okay.
is your mom on the phone again?
Yes, she's working from home.
Okay, we can keep this up, and if we come to other things, we can keep adding to it as we go through. So we are going to continue on with our notes. So I'm going to have to open that up.
No. Come on, man.
Oh, let's see, where am I at?
Who are we missing?
Brandon and Carson.
I thought Carson was supposed to be done with work. Was he continuing?
He was supposed to be done at work, but I have no clue. So
That's all right. We'll record this for them.
okay.
So when last we met,
Yeah,
we were talking about what the elements were,
Can I?
that they cannot be broken down. We're just going to do a quick summary and then add on. Okay, so our elements cannot be broken down into smaller units unless you want to blow things up, and then you can split the atom. But otherwise, don't do it. The symbols come from Latin, English. They also come from Greek, so probably should put that in there. We talked about some of the basic symbols were. Your fun fact was 90% of the body was made up of carbon, oxygen, hydrogen, and nitrogen. And this is where we left off at. Yes?
Yes.
Yes.
T.
Okay. I thought so. Was there any questions on any of those things leading up to this?
No. Yeah, no.
No? Okay. So we start off with atoms being the smallest part of an element. Okay, making them up. You cannot break it down without losing the properties of that element. Okay, so you can change the atoms around in the element, but it's going to change what that element is or what that element does. Okay, each of them have 3 particles. Okay, they have the proton, the electron, and the neutron. Protons being positive, electrons being negative, neutrons being neutral. Okay, I think we probably remember that from our former science days. Okay, the protons and neutrons are in the nucleus. The electrons spin around the outside. I'm trying to remember if we have a picture in the notes of this or not. Nope. Okay. On today's the day, Wednesday. So that means on Monday we'll have some pictures and we'll deal a little bit more with that as far as what that looks like and how that works. Okay. The atomic number, so if we were looking at the periodic table, the atomic number is equal to the number of protons, and the mass is if we take the protons and the neutrons together. Hey, we good?
Yeah.
Okay. Nice. Okay, so these things can vary a bit. Okay, so things change. So if an atom gains or loses an electron, okay, it ionizes. It's the term that they use. So it becomes a positive ion when it loses an electron. So at its base, atoms are balanced. They normally have the same number of protons and electrons. Okay, so it's like -2 and a +2 cancel each other out, so they stay balanced. Okay, so if it loses an electron, that means it's going to have more protons, so it's going to be more positive. Okay, then it's called the oxidation process, so it's oxidizing. Okay, if it gains an electron, and we'll talk more about what that means, then now you have more electrons than protons, so it is negative. And that's the process called reduction. Okay, we can relate that to life too. The more positive things you have going around, okay, the more positive influences you have, you lose that negativity. Okay, maybe a bad attitude or a bad day or something like that. You lose that, you're gonna have a more positive outlook. You gain more negativity, probably gonna be more negative as it goes. Okay, it is called an isotope when neutrons are lost or gained. So that is its special name. For that. Okay. Let me know if I go too fast or if we need to go back to something. Totally fine. Molecules are a precise arrangement of atoms. Okay? And then they get from the different elements. So when we start putting atoms together, then we get the molecules. So this would be the case where they make those compounds. So if we make water, we have 2 hydrogen atoms, 1 oxygen atom that gives us water. Okay, oxygen as a gas is 2 oxygen molecules together. Linking up there. So that creates the compounds. Okay, compounds we can break apart into their different base elements. Okay, so they create the molecule through some different types of chemical bonds. Okay, so they have to be close enough to share electrons. That's the key. Okay, so we have 3 different types of bonds. And we have an ionic bond, is when oppositely charged ions get together. So you have a positive ion, you have a negative, okay? That old saying that opposites attract, okay? And through that force of attraction, they hold together. Okay? A covalent bond is when they actually share electrons. Okay? One doesn't go over to the other, they just kind of link together and share. Okay? And then the third type is the hydrogen bond. So when your hydrogen nucleus, okay, which has the protons in it, to negatively charged atoms in the neighboring molecule. So your hydrogen bonds, okay, are a little bit stronger, okay, and they're specifically with a hydrogenated nucleus. Okay, so those ones, we'll probably be talking more about the ionic and covalent, okay, but hydrogen is in there. At the same time. I think in your book. There are pictures of this in your book for right now on page 23. You can see what that looks like. As I say, Monday we'll have some videos of this to help us visualize it as we go through. Oh, and then I have to clarify, I misspoke. That hydrogen bond is a very weak bond. It's like the water, the cohesiveness of water. It's not a very strong one, okay? Which is a good thing because then we can create steam and ice and we can change water's properties around. Okay, then we get to talk about how some of them are acids and bases. Okay, so acids are chemical compounds that release hydrogen atoms when they're added to water. The stronger the acid, the more that they will release. The weaker, then the less. Okay, bases attract hydrogen atoms when they're added to water. They're also called alkaline. Okay, and they use the scale, the pH scale, to measure the acidity or the alkalinity of it. And what they're actually measuring is the hydrogen ion concentration. Okay, so 7 is neutral. It's kind of the middle of the scale. The higher you go, the more basic it is. So that means the less acidic it is, and below 7, the more acidic it is. If we, on page 25 in your book, it gives a little chart of some basic body fluids and their acidity. Kind of interesting, saliva is a 6.8. Okay, so it's not very acidic, but it is a little bit. Okay, whereas milk is a 7.1. Your tears are a 7.2. So thankfully they're not very acidic. Otherwise that would burn when you cried.
What's considered very acidic?
So so if something measured in like a 1 or a 2, that would be very acidic. Like the acids that are in your stomach that are used to break down foods is very acidic.
So the lower it is, it's
correct.
Okay.
The lower the number it is, the more acidic it is.
Okay.
Okay, then this is the fun part. Okay, we get into carbohydrates. Okay, so these are special chains of molecules. Okay, they build pretty much everything. Okay, and it's your body's #1 source of energy, comes from the carbohydrates. Okay, so this is when we start to get into the organic compounds, things that build up life. Okay, so our carbohydrates are composed of our carbon, hydrogen, and oxygen in different forms. We can also call them saccharides. Okay, so your simple carbohydrates, okay, your simple sugars. Sugar is another name for carbohydrates. Pretty much anything that is a carbohydrate is going to break down into some form of sugar in the body. Okay, so your monosaccharides are the simplest form of it because they're single units and they are very easy to break down. Okay, so glucose is your blood sugar. Okay, so when you eat, the body digests your food and gets that glucose into the blood system so that your cells can use it. Your brain functions on glucose. Okay. Then you have galactose is another form that your brain, the cells will change that glucose into galactose so it can be used by the brain specifically. Fructose is what you find in sugar. Okay, are we seeing anything in common between these three? yet. I can't highlight. Well, we'll see what they all have in common here. Okay, disaccharides, okay, are two monosaccharides bound together. Okay, so now we're getting a little more complicated. Okay, so maltose is a breakdown of starch. Lactose is found in milk. Sucrose is found in table sugar. Breaks down into that. And then your complex carbohydrates are the polysaccharides. So these are the many chains of monosaccharides or disaccharides listed together. Okay, so if we get thousands of glucose units together, that creates the starch. Okay, that is what your body stores carbohydrates as. Okay. Glycogen is where it stores it in the body, in the cell itself. Cellulose, your dietary fiber. Okay. The cellulose is very hard for the body to break down. Okay. So that's why fiber is good, because it doesn't get broken down as easily, so it helps go through your system to kind of help flush everything out, because your body has to push it through because it can't digest it down. So hopefully we're catching on that most of our sugars here are all going to end in ose. So pretty much any compound, if it ends in ose, it is some form of sugar. If you like looking at pictures, on page 26 and 27 in the book, it gives you some pictures of what the chains look like in the formation of the molecules, but you will not have to have that piece memorized, okay, as far as what the molecules look like. Okay, we're not going to be that detailed in our work. Okay, so we have carbohydrates that make up our body system. Okay. Then we have our lipids. Lipids is the very polite way of saying fat. Okay. So it's the same thing. Okay, used for energy storage, thermal insulation. I like the shock absorption. Okay, you have to have a little bit of padding, so if you fall down, you just don't crack things. Okay, steroids are broken down by fat, so they build our hormones and our body's chemical regulators. Okay, so they come into this section because of how they are used. Okay, they're also considered waxes. So when you have a buildup of earwax, that's a buildup of lipids in your ears. Okay, fat is a mixture of glycerols and fatty acids, also still made up of your carbon, your hydrogen, and your oxygen. Okay, different types of fat. So the amount of the fatty acids that are in the chain will help us find its name. A monoglyceride means it has one fatty acid chain in it. Okay, unsaturated fats, you'll see this if you're looking at labels and are reading labels of food. Unsaturated fat is double bonded, which means it has more hydrogen in its chemical makeup. It means it's easier to break the chains apart. Okay, saturated don't have those double bonds, harder to break apart, and that's why saturated fat is considered a bad fat, because your body can't break it down. Okay? It's either going to store it, or it's going to sit in your arteries, or it's just not good for you at all. Okay. So it comes into play there. Inside of your cells, there are globules. That's just a fun word to say, globules. Okay, where the fat is stored in the cells. Fat is a quick source of energy for the body to use, and so if it can break that down, it'll store that. If you are looking at your body and kind of pinching your tissues together and you're saying, oh my goodness, look at that layer, that thick fat, that's the adipose tissue that you're looking at. Okay, so those adipose tissue hold those globules that contain that quick use energy. Okay, so when your body is burning energy, it's going to burn what's in your blood system first, and then it's going to tap into your tissues. Okay, so if you eat a meal and then you go work out, whatever was in that meal, your body's going to use first. And then it's going to go into the tissues. A lot of people that are trying to lose weight or diet, they're trying to get at this adipose tissue, which your body has to get through everything else first. Okay, so it's possible, but it's a little bit harder to target, okay, as your body goes through. Okay, all of these things, the fats broken down by lipase in the digestion process. And that lipase in there, it breaks down the different types of fats, okay, into the fatty acids and into the cholesterol so that your body can use it in different ways. Any questions? We're kind of throwing a lot of information here. Right. The last one we're going to talk about today, the last organic compound is protein. It is our catalyst for pretty much everything. It's our building block of our muscles, our hormones. Hormones and vitamins, they're either fat soluble or water soluble, and the water solubles come in and work with the proteins to tell the body what to do. And so that's where that comes in too. Okay, proteins are made up of amino acids. Right? The link between them is a special type of bond called a peptide bond. Okay, peptides, fancy way of saying small proteins. A nice, easy way of saying that there. Okay, enzymes are proteins that catalyze most chemical reactions in the cells. So catalyze means to break apart. Okay, so when we are talking about metabolism and catabolism, breaks things down. So proteins, the enzymes are special proteins that do that. So pretty much every chemical reaction. So in the notes there, RXN means reaction. I just didn't feel like spelling it all out. We use the enzymes to break those things down. They are the major components of our bones, our muscles, our connective tissues, and our hormones. Whoop, we're not getting to that today. I think we'll get into it at a later, that with the amino acids, there are 13 basic amino acids, and your body can make most of it on their own. Okay, but there's certain ones we can only get from our food. So that's why we want to have a well-balanced diet so that we can make sure we're getting all of our amino acids. Can't pull up the color. Okay, how we doing?
Good.
I have to write down the last 2 points because when I printed it off, it screwed up somewhere, so I don't have any of this.
Uh-oh. From where the two as in enzymes and components, or protein and lipids?
enzymes and components. Like that's what it looks like at the top of the paper. It's just
Yeah,
messed up.
that's unfortunate. Well, at least it's only a couple of lines as it goes through there, at least. Okay, from here, if we need to go back to anything, we can go back to it. If we need any more explanation of things, we can do that too. We are going to, on Monday, delve into a little bit deeper on some of the things we've gone over. We'll get to the DNA part last, but that's okay. Keep looking for our punny ways of using our
Tim has one.
Okay. I heard that we have another one. but
Tim
I'm gonna
does.
have- kind of.
Tim does.
Oh, Tim does.
Yes, he does.
This
Yes.
is valid.
Does. Okay. So, am I good to close this, or do we still need it? Okay. So I'm going to stop that share. I'm going to come back to here, and I'm going to come to this one, to this one. All right, Tim, what do you got for me?
What do you say when oxygen, hydrogen, sulfur, sodium, and phosphorus walk into a room?
Oh my goodness. When sodium.
Oxygen first.
Oh, oxygen first.
Yeah,
My bad.
it goes oxygen,
Oxygen, hydrogen,
sulfur,
sulfur,
sodium,
sodium,
and phosphorus.
and phosphorus walk into the room.
Yeah. Oh, snap.
Wow. That's good. That's good.
Nice.
There's Keith. I got one, but it's kind of lame.
Okay, well, let me make sure I got this. So, wait, I'm missing something.
The N is supposed to be capital.
The N is capitalized and the A is not. Okay, that's that. Whoop. Okay. I'm gonna make these different just so it doesn't look like they're all one thing. I'm gonna back that up so it's all right there. Nice. Okay, what was our other one?
I don't know. Are we only doing certain amount, like certain ones from the sheet, or can I go like one that we're not doing?
Well, let's see what we got and see if it's worthwhile throwing it on here.
I would tell you some chemistry jokes, but all the good ones are gone.
I get it.
Tell you some. And then
Har har, Suka.
jokes,
Very
but
funny.
So funny.
I don't get it.
all the good ones are gone.
Argon is.
Argon. There it is.
Can't believe you went there.
You're welcome.
I'm very
And then
disappointed.
if we
in
throw a
Suka.
hyphen between
Very
argon,
disappointed.
argon is AR, right?
Mm-hmm. Wait, let me go back. Yeah.
Okay. All right, so we'll delve more into these on Monday. We'll keep adding to our list. I'll save it and then figure out a way to easily get it to you. That was easier than the last one we were on. And then we'll meet up again on Monday.
No fun.
So no homework?
So no homework. I would maybe start reviewing your elements and their symbols. Make some flashcards with them. something to help you get going on that process. But as far as something you have to go do, no, not yet. I think we'll be okay with that.